an issue. We'll start. Good morning, ladies and gentlemen, colleagues. I welcome you to this second session of our conference. Today we have 4 speakers in this session, and I remind the speakers that we'll try to stick to the time, so please be brief and leave 5 minutes for the question and answer period. Is our first speaker with us?
Yes.
Okay, great. So, ladies and gentlemen, our first topic for this session is towards environment-aware wireless networks, current concerns and next generation green techniques. It is will be given by Professor Mohamed Salim Alouini. I hope I'm pronouncing that correct, Professor.
Alouini.
Sorry, Afwan?
Alouini.
Alouini. So Professor Mohamed Salim Alouini, Distinguished Professor of Electrical and Computer Engineering at KAUST. As I said, for those of you who don't know KAUST, King Abdullah University of Science and Technology at the Kingdom of Saudi Arabia. Professor Mohamed was born in Tunis. He received his PhD degree in electrical engineering from California Institute of Technology in 1998. He served as a faculty member in the University of Minnesota, USA, then at Texas A&M University at Qatar, Education City, Doha, before joining King Abdullah University of Science and Technology, where he is now a professor of electrical engineering. Professor Mohamed general research interests include design and performance analysis of diversity combined techniques, MIMO techniques, multi-hop cooperative communication systems, optical wireless communication systems, and a whole list of other research area where he has published several papers on these topics and subjects, and he has co-authored a textbook on digital communication over fading channels, which was published by Wiley Interscience. He has also won several awards in his career. So it's a short bio, but please, Professor Mohamed, please start your presentation.
Thank you very much, Dr. Usama, for this nice introduction. Assalamu alaikum, everyone. I would like, of course, to start by thanking the organizer for this kind invitation and for this opportunity they are giving me to share some of our thoughts with the Arab ICT Forum 2020 audience, in order to talk about, our kind of, again, thoughts on this topic of environment-aware wireless network. So let me share my screen so that you can all see my view graphs. Do you all see my screen? You see my screen, right? Yes, okay. So obviously, let us start by talking about this so-called mobile revolution. Some argue that mobile is the most rapidly adopted consumer technology in history. This is in one way the result of the merger of the internet, electronics, wireless communication, and networking. So today, as you know, we use our mobile or tablets to make phone and video calls, order things online, check time and location, access also sort of entertainment like listening to music, watching a movie, and many more things. So it's kind of kind of amazing that what was regarded as independent services and independent function, I would say even different tools and different devices just a few years ago have been kind of integrated over the last decade or so in a single mobile smartphone. But of course, we still want more. in the sense, as user, of course, we want more coverage, more connectivity, higher data rates, better access anytime and anywhere. And all of this, we want it to happen, let's say, in a cheaper or in a more affordable fashion. And actually, these increasing demands are something that we have seen constantly over the last 4 decades. So 1G was in a way the proof of concept stage, and it brought us in the 80s the first mobile phones. During the 90s, 2G made us move from analog communication to better quality digital communication with both voice and texting exchange capabilities. Then came the 3G era in the 2000s, and with it we moved from let's say an online era. We start browsing online internet from our own mobiles, and we are now enjoying the high speed provided by our 4G smartphones, and this speed is expected to go even to higher values as we start deploying 5G, and this is happening as we speak in many cities worldwide. So as you can notice from this view graphs in front of you, it takes about 10 years to design, develop, validate a generation of mobile communication system, and it takes another 10 years to deploy it, expand its usage until it becomes mature and it gets eventually retired so that the following generation gets adopted. So you can easily guess that as we start deploying 5G these days, we have started, and here by we mean like the research community in wireless communication, both from academia and industry, we start already brainstorming about what should 6G be. So it's kind of speculative period of time. Sorry. It's a speculative period of time, and there has been kind of quite a bit of paper over the last year and a half or so talking about beyond 5G and 6G network and how they are going to push the envelope with kind of higher speeds, more user capacity, lower latency. So we can say that the 6G train, towards better performance and better quality of service is actually moving quite fast. Now, retrospectively, when we look at this historical evolution of mobile network, the initial goal was to bring basic connectivity to user over a wide coverage area. Then this evolved towards improving the quality of service of cellular networks by boosting their throughput and capacity. This explains why data traffic of wireless network is going at a rate of, let's say, roughly 1.5 to 2 times per year. So if this trend continues, the cellular network are expected to handle maybe kind of handles, if not 1,000 times more data traffic in 10 years from now, in 2030, at a time when the 6G networks are expected to start being deployed. Now, let me open a parenthesis now and look at some important other trends. So in a more general context, let's say, the world is becoming far more urbanized, and mega cities with population greater than 10 to 20 million people are emerging here and there. There is obviously a much great need for large-scale operation and management for these cities to effectively serve the inhabitants of these cities. And actually, in another hand, there is this desire to slow down or even reverse this strong urbanization trend. Now, this can be done in the framework of the so-called United Nations Sustainable Development Goals, in short SDGs, which were adopted a few years ago, which include all these kind of interesting and noble goals targeting issues related to the environment, health, education, food, gender equality. Of course, elimination of poverty also is an important aspect, and which incidentally, these goals are supposed to be achieved by 2030. 2030 is going to be this critical time where we have the SDGs goal to be achieved, but also where our expectation of the first generation of the 6G network are starting to be deployed. And our hope is that the next G, the 6G network, will address some of the important concern, or let us say the blind spots that we have seen in the early deployment of 5G and more generally in the previous generation of mobile communication systems. So the first concern, and I will not spend too much time on that, is related to this connectivity divide. I gave about a year ago a talk in Bahrain, and I got into really details on this topic. So I will not kind of go more into it. But this digital divide, this connectivity divide, actually is an important problem. About half of the population is not connected. The pandemic showed how this topic is actually becoming so important, where people basically are missing a lot of information, a lot of service because they are not connected. Some jobs cannot be saved because of this lack of connectivity, because of this lack of digitalization. So this is definitely one blind spot that we need to address as part of 6G deployment. Another important blind spot is essentially this concern that is related to power consumption. Indeed, according to a recently published white paper, cited in the slide in front of you, initial measurements based on this kind of recent 5G real-world deployment, essentially in China. China has a little bit of a heads up on this compared to other countries. So these kind of white paper are reporting that the power consumption of some bands of 5G equipment is up to 3 times of 4G with the same configuration. And number two, our second set of conclusion is that the number of sites is expected to be 3 to 3 times that of the 4G era in order to achieve 4G equivalent, let's say, coverage. And this is, of course, true in, let's say, in dense urban environment. So this significant increase in the number of base stations obviously is a problem because it means that there is also an increase in power consumption. And this will not only kind of lead to kind of accentuation in the negative environmental impact of cellular network, fossil fuel consumption, but also will bring some kind of financial pressure to major MNOs due to the expected increase in their electricity bill. And this, of course, in return will make the subscription or the rate of these MNOs more expensive for the end user. The third concern I would like to talk about is that this increase in power is also kind of related in a way, at least in the mind of people, in this kind of increase or concern on electromagnetic field, in short, EMF exposure. And this is concern that we have seen in the general population, and this led to all of this unfortunate kind of, I can call them fake news in the last spring when the early 5G kind of system started being deployed with these kind of arson attacks in many countries, including UK, Ireland, Australia, and so on. Now, based on our really extensive studies that I have seen in the open literature and that we kind of cited in this paper that we just submitted as going through the review process, I don't think there is really compelling motivation to stop the deployment of 5G. Essentially, when the regulations are applied, they are very strict, and I think we are operating in a safe regime, at least from a kind of thermal or RF effect perspective. However, this doesn't mean that we should not continue doing research on possible health effects associated with some realistic exposure level below maximum tolerated, let's say, limits for 5G equipment and device and beyond 5G. Again, nothing proven at the present time, but this is something that we need to look at least from a biomedical perspective, in particular in the emerging millimeter wave terahertz band, and also to look at beyond thermal effect. Is there some other kind of biological mechanism that can essentially lead maybe to harmful diseases like cancers or cardiovascular diseases? So that's like one research direction that has to be kind of pursued, mostly actually by biomedical engineers or scientists. Now, as telecom engineers, we need to expand the research works from the device architectural network perspectives, as well as kind of take into account health regulation, so that we design, let us say, radiation or, if you will, EMF-aware cellular network, which means we would like to deliver cellular network that can provide the right quality of service, the right performance, but with minimum EMF radiation that are, of course, below the set regulation that is set now, or that can be revised in the future if it turns out that the regulation set more strict regulation. So essentially, if we address these three concerns, starting by this concern of bridging the digital divide, with 6G kind of relying on these satellite communication systems and HAPS, HAPS stand for High Altitude Platform, to bring this global connectivity. Now, hopefully, we can provide this high quality global connectivity, and essentially we can break this vicious digital divide cycle and enable, let's say, richer, denser communities to share their knowledge and strengthen essentially the economies of less fortunate, more sparsely populated communities. And once we truly achieve global connectivity, once we can take advantage of the expected technological advance, with the IoT, for example, we can basically move out of this, in a way, smart concept, narrow concept of smart cities, and move to the kind of broader concept of smart hamlets, smart village, smart farms, smart rural areas, in short, smart living. I mean by that, an environment where one can enjoy quality healthcare, quality education, without being in a congested downtown area. And this, essentially can take place overly, or of course, in less populated and not necessarily very dense, urban environment. So this quality living can obviously be enjoyed without having to move to a big city, and this may or this may lead, let's say, or trigger a counter-urbanization phenomena that we have not seen in the past. And that's, as I mentioned earlier, probably one desired effect when we see these kind of huge migration and this kind of emergence of all of these megacities. To address the second concern, one interesting emerging technology is known as intelligent reflecting surface. It's known also as artificial radio space or smart radio space. And here, what we are doing, basically, the wireless propagation environment is turned into an intelligent, reconfigurable space that plays an active role in transferring radio signals from transmitter and receiver. So essentially, the idea is to reflect or to mirror the signals without having to add extra power into areas where we have not spots, where we have bad coverage, without having to add extra power. So it's illustrated in a very simple way in these two small figures that are in the right of your view graphs. You see on the left side, like this red zones that are kind of not spots, areas that are not very well covered because of obstruction. As soon as you start using this reflecting surface, like basically painted, let's say, on the facade of some buildings, essentially you can convert like many of these red zone into green zone, and essentially allow yourself to enjoy a much better coverage, a much better connectivity without having to add extra power in the network. Another interesting technology that hopefully is going to pick up as part of beyond 5G or 6G is known as visible light communication. So, it provides essentially optical fiber-like performance, but relies on visible spectrum, which is, as you know, portion of the electromagnetic spectrum that is entirely untapped, free, safe, and basically provides a high potential bandwidth to piggyback on energy efficiency. So today, VLC demonstration show roughly 100 megabit per second capabilities, and the objective is to kind of deploy in practice what we are seeing in labs now, basically multi-gigabit per second capabilities. So there is obviously great potential here in view of the expected scarcity and maybe even deficit of RF spectrum in the future. Another interesting solution when we talk about the energy efficiency is essentially IoT and backscattered communication. So as you know, IoT is becoming part of our lives for smart homes, smart cities, smart factories. And here we can rely on energy harvest-based communication techniques, or more radically, actually, one can enable sensor to run on what we call battery-free fashion, basically by retro-reflecting ambient RF signals using, say, on-off modulation type schemes without the need of any active RF transmission. This is known as backscatter communication, where basically you take advantage of the surrounding RF sources to communicate in an energy efficient fashion. One last technique of course, relies on what we call green mobile networks. So in order to achieve considerable energy efficiency gains, limiting our effort on individual transmission links is, of course, not enough. And in this context, it's expected that mobile operator will be increasingly deploying renewable energy generator on the site of their base station. This is particularly critical in some rural remote environment where the power grid is either unavailable or not reliable. And it's anticipated to be also more popular for urban environment where this can be combined with, let's say, on-off switching, green mobile operator collaboration, renewable energy exchange, and even cooperation with the smart grid, let's say. So these are some of the approach that we are studying and that can eventually be adopted to reduce the energy bill and correspondingly the CO2 emission of mobile operator. I have a few more minutes. I would like to remain on time. I will skip some slides, but basically what I would like to highlight, another important trend in beyond 5G and 6G is to start relying more and more on UAV, basically, or drones as flying base stations. Obviously, drones can provide better, essentially, link quality because they can put themselves at the right altitude to create a line of sight with the end user, and they can follow the traffic. The main problem with what we call regular untethered UAV or untethered drones, they have a limited flight time because of their limited battery capacity. So one really key research topic we have been investigating over the last couple of years is how to rely on what we call tethered drones. So this is not science fiction. Of course, they are available. You can buy them from the market. And the idea is to connect the drone to a cable, quite long cable, 150 meters all the way to 200 meters. And the cable or the tether is used to put both power and backhaul, so like a fiber optic. So basically, you can hover over kind of a cone, like it's illustrated here, and essentially create the best line of sight, but you are always having the right amount of power supply, and you are backhaul to a ground station on the ground to be able to exchange information with the internet backbone. So obviously, if you compare tethered drone versus untethered drone, you win big time in terms of endurance, in terms of how much payload you can carry, which means essentially you can have a really flying base station putting itself at the right altitude, at the right position to create the best possible channel. Now, we use that to basically design the so-called EMF-aware or EMF-friendly cellular networks. Now, believe it or not, people sometimes have this misconception. They think that most of the radiation are coming from the base station. Actually, if you are not very close to base station, the level of radiation is minimal. So there is not much actually radiation coming from the base station. Most of the radiation that is affecting you and may affect your health is coming from your own smartphone, your own laptop, your own tablet, because it's close to you. And if you are operating in a regime or in a particular area where you are far from the base station, basically what's going to happen is that essentially your tablet, your mobile is going to be transmitting at high power for the uplink to transfer information from your mobile to the base station. And this is where you get maximum exposure. So our idea is to create what we call a decoupled network, a network where you get your downlink from the faraway base station because it's harmless, but basically for the uplink, you send drones close to the users and you make these drones basically locate themselves in an optimal location given a certain cluster of users in order to basically create the best possible channel, which means that the user will be transmitting at minimal power. So the uplink is done with the drones, the downlink is coming to the base station, a decoupled, and we call that green TUAV. Green in the sense the UAV are there only to listen, only to receive information, but not to transmit and not to essentially create radiation to the end user. And we showed that here we can get up to 50% gains in terms of reduction in EMF radiation for the same quality of service. So it involves, of course, some interesting mathematical problem formulation and solving it using some heuristic algorithms, the k-means or the shrink and realign algorithm, in order to place the drones in the best location within a certain user population deployment and to associate the right user to the right drones. With that, I would like to thank you for your attention. And as telecom engineers, we have no choice. Had to keep pushing the envelope to try to fulfill this interesting prophetic kind of prediction made 100 years ago by Tesla. But clearly, 6G has to be done in a sustainable fashion, in a green fashion, and we hope that the vision we have for 6G will be the vision that's going to prevail, and the kind of 6G network we'll be seeing in 2030 will be green and will be sustainable. Thank you for your attention again.
Thank you, Professor Mohamed, for this wonderful presentation, and really thank you for being right spot on time. The floor is open for questions. If anybody has any question, please feel free to enter it into the Q&A. While you are considering your questions, maybe you allow me to ask Professor Mohamed. You have gave us a good review of the challenges regarding designing environment-friendly communication and information system. Can you give us a summary from your opinion? What is the best approach to design and operate a system with minimal or no impact on the environment? I mean, considering that this may be a futuristic question as well.
No, it's a very interesting question, and actually it's not an easy question, because if you really want to go deep, you need even to know, you need to even investigate, and this is something that's being investigated as we speak, because people are really paying more and more attention about this sustainability aspect, which is not only actually, the power you use to run the network, but also the energy that you need to fabricate, to construct base station, to maintain them, from which material. So if you look at the whole kind of chain, it's a quite complicated question, and people are still thinking about how to answer that. But now, if you limit ourselves to the power consumption aspect, I think this, as I alluded to in my presentation, that there are different levels where we have to intervene. We have to intervene at the link layer level, which means if you can use some energy harvesting mechanism, if you can use some adaptation, which means you don't always transmit at maximum power. When the channel isn't good, maybe you can back off and you can save some energy. So, this is some of the link layer solutions. But also there are solutions at the network layers. You can start using more renewable energy to kind of power your base stations, like solar power or wind turbine. And in some areas, actually, that's the only way to power your base station. And also there is this kind of idea that we pursued a few years ago, and we wrote a couple of papers on that, is this concept of on-off kind of operation of the network, which means, as you know, the traffic demand are not uniform over the day. So over the maybe day peak time, you need to put a lot of base station on, and you'll be operating at full capacity. But then during the night, where basically, there are only few people kind of operating and talking and exchanging information, you can basically put some of the network to sleep and save energy that way. So in summary, what I would like to say, saving energy has to happen at different layers, and there are different techniques that complement each other in order to reach this objective of green communication and networks, which is, by the way, now a field by itself. We now have an IEEE, a technical committee on that. We have a transaction on green communication, just to tell you how popular is the field and how important is the field.
Thank you, Professor. I have a question from one of the audience. Is there any standard platform for a smart city form your team is going to support and which is going to support several services within the city? So is there a standard platform?
I mean, I'm not sure what is meant by standard platform. I mean, of course, in our studies, there are different kind of expertise, different kind of research, let's say, styles. In my group, we look more at models, and we start with models that try to reflect reality or capture reality in a way that is, let's say, sophisticated enough to kind of capture the kind of phenomena we would like to describe, but simple enough to be tractable mathematically. And then often we go and just do some analytical work using some like mathematical tools in probability, stochastic geometry, optimization, in order to come up with solution, and then we can generate some numeric result to learn some lessons or to, to give some guidelines to operators. Now, of course, if you want to go closer to reality, you need to use simulators. This is not typically my style of research, but there are very good teams worldwide who develop this platform, these simulators, who try to emulate a real system, and then before deploying it, just to check, how basically new techniques or new schemes essentially perform. But typically, this is not a good idea to start right away with the platform. It's good to do some interesting studies, try to learn some lesson, try to see some trends, so that when you move to a platform or to a simulation, at least you have some initial guidelines, initial ways how to tackle the problems, and initial ideas, what are the things that you would like to test.
Professor, I presume the question means or implies that to have smart living, you need a lot of systems to be interconnected. And the question I assume is that, is there a standard format that has been developed to allow all these different systems to communicate together and collaborate together, or this is still in an early research stage?
Of course, nothing is completely solved, but we know how to connect things. The key point when I talk about this concept of smart living and to how to connect remote areas is how to backhaul, how to reach these remote areas, and how to backhaul that. Obviously, fiber optics don't work always, but how to connect these remote systems. The system can be the same, by the way. A village doesn't mean that it has to use a substandard system. Once you are in the village, once you are connected, it can be exact same system that we'll be using in downtown. But the problem is how to connect that village to the data centers, to the backbone network. So the backhaul, this highway of information that will make you connect these living smart living environments, smart communities, is the big challenge that we need to solve in the coming years. And how we solve it? Through maybe satellites, through hubs, through basically aerial solutions.
Thank you, Professor. Which brings, this is the last question from Mr. Ovidio Bogdan. You mentioned the drones, and he's wondering why not satellites? Isn't satellites would be a better and an easier form of at least filling the gap that you mentioned in terms of connectivity divide?
This is an excellent question. Unfortunately, we don't have all the time to get to the details. I can spend like 10 minutes talk about that, but let me try to give a short answer. Of course, there is a big emergence of satellite communication, but satellites are good for backhaul. If you are going to design satellites so that you talk direct to the phone, this didn't work in the past. People don't want to have a special phone for satellite. People want to use the same phone they are using everywhere else to communicate in an area where they are unconnected or they lose connectivity, which means you need to use 5G or eventually 6G. You don't have to have a special standard for satellite. What does it mean? It means that the user on the ground needs to talk to an intermediate kind of base station on the ground or in the air, like a drone. But you use your standard phone, your Samsung Galaxy or your iPhone, to connect to that terrestrial relay. And the job of the relay, the drone base station, is to backhaul the satellite. But calling directly the satellite, the budget link will not allow you to operate with a good data rate. You cannot. And also, the satellite network are much more expensive, by the way. It's much easier to deploy a few drones than just launching these thousands of constellations where people are struggling. Unless you are Amazon or you are basically with Kuiper or you are SpaceX with Starlink, not everyone can just start launching satellites right and left to have a global connectivity.
Thank you, Professor. I really enjoyed talking to you on this subject, and I would like to have had more time, but we need to move to the next speaker. Really, thank you very much on a wonderful insight. Okay.
Thank you. Thank you, Dr. Usama, and I hope that we'll have an opportunity to all meet, after the pandemic time and meet face to face in some of the upcoming conference and events in the region. Thank you for your attention.